Okay, so this question was a commonly asked question. This says, let f of x be the function whose graph is shown below. And we see that this graph is made up of two linear segments, one that goes like this, and then one that continues on from this point to this point onwards. And we're told to evaluate the limit as x approaches 1 of this function right here. Now, at first, this might seem scary, but it's not as bad as it looks. All you have to do is solve this just like how you would with regular limits, like you always do. All we're going to do is we're going to first try direct substitution, and we'll see what happens. So plugging in x equals 1, we get f at 1 minus 3 divided by 1 minus 1. Well, f at 1 is going to be 3. So that's going to be 3 minus 3 over 0, which gives us 0 over 0. And as you know, 0 over 0 is one of the forms of indeterminate. And when we get an indeterminate form, we need to figure out a different way to evaluate the limit. And one way we could do that is by using L'Hopital's rule. L'Hopital's rule can be used whenever you get one of the 7 forms of indeterminate, where 0 over 0 is one of them. In L'Hopital's rule, you simply just take the derivative of the numerator and the derivative of the denominator separately. It has nothing to do with quotient rule. All you're doing is just taking the derivative of the top and then dividing by the derivative of the bottom. So that's what we're going to do. And as always, whenever you're doing L'Hopital's rule, we want to make it clear to the person reading our work what we're actually doing. So when we do this, we want to write an equal sign with LH to represent that we're using L'Hopital's rule. So we can say the limit as x approaches 1 of the derivative of the top, which would just be f prime of x, and then this minus 3 will go away because that's just a constant. And likewise, below, the derivative of x is just going to be 1, and the constant negative 1 is just going to go away. This leaves us with the limit as x approaches 1 of f prime of x. We can now go ahead and try direct substitution, where we're now going to get f prime at 1. Now here you might be worrying, and don't worry, it's not as bad as it seems. We're told to find the derivative at x equals 1, and we also know that the derivative is the slope. And in this case, because this graph contains linear segments, that means that the slope is also the average rate of change, and that's also the derivative. So we know that the slope is just y2 minus y1 over x2 minus x1. Therefore, we can use 2 points from this graph, and ideally I want to avoid decimal points, so I want to use the ones that will be easiest for me. So for example, I can use 1 comma 3, and I could also use negative 1 comma 2. And really, you could use any of the points from this as long as it is within this line itself. You cannot use the ones from here because that will give you a totally different slope. And then this point could be x1, y1, and this could be x2, y2. Now, it doesn't matter what you call x1 and x2 or y1 and y2. It just has to be consistent. So you can't call one of them x1 and y2. And when you plug it into the equation, it has to stay consistent. So we know that f prime at 1 is also the same thing as saying y2 minus y1 over x2 minus x1. And then plugging in our points, what we're going to get is y2 minus y1 over x2 minus x1. And then simply, we're just going to get 1 over 2 as our final answer.